So in trying to define what the Mediterranean was for him, the great French historian Fernand Braudel came up with this definition. The Mediterranean is 1,000 things together. It's not one landscape, but numerous landscapes. It's not one sea, but a complex of seas. It's not one civilization, but a number of civilizations piled one above the other. And considering this diversity, it should perhaps come as no surprise that the Mediterranean should almost naturally be considered as a laboratory for studying human-environment interactions, but also as a privileged meeting ground for archaeologists, historians, and environment specialists. And it is interesting to note that in the last few months, several workshops were organized on themes closely related to this event, starting with the early Middle Bronze Age transition in the ancient Near East, held in March in Chicago, followed by another event held in Aix-en-Provence, titled Interdisciplinary Meeting on Climate Change and Seismic Hazards During the Holocene in the Mediterranean. And the very last event just ended a few days ago and was held in Halle in Germany on the 2200 BC event. But this is, of course, without counting a score of other events that have been organized in the past, among which the 2008 Baeza workshop that was published in 2011 as a special issue of the journal The Holocene, and also a series of books and articles, some of them published by our speakers on closely related themes. But nevertheless, I'm pretty sure, at least as far as I know, that this event is the first one specifically dedicated to environmental and climate changes at the end of the Bronze Age in the Mediterranean. So here is the overview of this short presentation. So I will, of course, this event brings together environment specialists, but also people who might be less familiar with environmental concepts. So I will spend just a few minutes introducing the main characteristics of the present-day Mediterranean climate, hoping to provide you with a basis to better understand the physical processes that are responsible for climate changes during the Holocene. Then I will detail for a few minutes what kind of data do environment specialists use to reconstruct paleoclimates, what is called paleoclimate proxies. And because food shortfalls can be considered as one of the most direct consequences of climate-induced stress, I think that any discussion of the potential impacts of climate change on ancient societies should take into account the most basic characteristics of how people were producing food. So that's why I will be discussing the question of Bronze Age subsistence and associated buffering mechanisms in my third point. And finally, getting back to the theme of this workshop, I will provide you with a brief overview of research that has been done in the last decades on this particular question of the role of climate in the collapse of Eastern Mediterranean Bronze Age societies. And I hope it will be clear from this overview that the role of climate in this whole series of events has moved from that of a driving factor to that of a mere contribution of what Eric Klein in his last book described as a perfect storm of calamities. So let's move with the most basic characteristics of the present-day Mediterranean climate, and I urge all the people, all the climate specialists in the audience to rectify what I'm going to say now in their own talks. But most of you have probably been to the Mediterranean, most probably during the summer, when the weather is hot and dry, and maybe a smaller amount of you has been there during the winter that are wet and mild. And how do we explain this strong seasonality, this strong difference between the winter and summer climate conditions in the Mediterranean? Well, we can explain that by the particular position of the Mediterranean right between two climate systems, the temperate westerlies to the north and subtropical high-pressure belts to the south. And as these two climate systems move northward or southward, well, we get the conditions that are hot and dry in the summer when it's mainly an influence of the subtropical high-pressure belts, and during the winter where we have a deeper influence of the temperate westerlies. The main limiting factors, according to Harding and colleagues, the main limiting factor to human life in the Mediterranean is rainfall, not temperature. And rainfall in the Mediterranean is characteristically related to centers of low atmospheric pressures that are typically, but not only, themselves associated with the lee of mountain chains. So there is, in fact, a whole series of mechanisms that influence the present-day Mediterranean climate, including jet streams, so these fast-flowing corridors of air that are about 11 kilometers from above our heads, but also large-scale pressure patterns such as the North Atlantic Oscillation, the Indian monsoon, cyclones, and also local wind. And I'm going to discuss a bit more the question of local winds because they also have a deep influence on Mediterranean sea circulation, not only on atmospheric circulation patterns, and their influence in Mediterranean sea circulation goes hand in hand with salinity and temperature gradients. And three local winter winds, mainly winter winds, are quite important in the Mediterranean, and they are here represented. That's the Mistral in the Rhône Valley in France. That's also the Bora in the Adriatic region and the Vardar in the region of Macedonia. And anticipating a little bit further discussions we will undoubtedly have on the collapse of Aegean Bronze Age societies, I can already mention that Elko Rowling and colleagues in 2002 suggested that during the Holocenes, there might have been periods of more intense, more frequent, and longer periods during which these winter winds were blowing from the north of the Mediterranean, with influence on the Aegean, because this study was primarily done on a core taken to the northeast of Crete. And it's also significant that Weininger and colleagues related these cooling events to rapid climate changes, RCCs, which again we will probably hear again about in the talk of Bernard later this morning, which are defined as Holocene global cooling anomalies with a periodicity of about 1,450 years. And why are these local winds or these periods of more intense winter winds important to our discussion? Because among the three periods that have been suggested by Rowling and colleagues and later by Weininger and colleagues, is that one of these periods nicely coincides with our transition, late Bronze Age, early Iron Age transition. And Brendan Drake, in a recent paper, suggested that the late Bronze Age, early Iron Age transition in the Aegean might have been characterized by drier and possibly cooler conditions that may have negatively affected Bronze Age agricultural systems and perhaps motivated the migrations that also typify this period. But although this hypothesis is probably a very seducing one, I must say that perhaps in the past we did not discuss enough the factors that control the resilience of Bronze Age agricultural systems, and perhaps this workshop is a good context to do that. So moving now to the next point, which basically tries to answer how do paleoclimate specialists reconstruct ancient climate, Holocene climates in the Mediterranean. Well, I've here listed a whole series of proxies commonly used. No worries, I'm not going to go through all of that, but this table will remain on the screen for a couple of minutes, so you can just have a look at the kind of proxies we use. But what's maybe important to realize is that some of these proxies are commonly used to reconstruct ancient temperature and precipitation conditions, whereas others, such as change in catchment hydrology and pollen, are used for retracing vegetation and fluvial responses to climate fluctuation. And very obviously, when we have these data, we need somehow to put them in a chronological framework. So there is a wide variety of dating techniques used to anchor these changes in absolute chronology. And it's worth maybe remembering this quote from Finet and colleagues, stating that each technique has specific limitations problem regarding chronological constraint, resolution, and accuracy affecting comparability between different paleoclimate records. And here, comparability is really the key word, since at the end of the day, that's what we will be trying to do, bring together archaeological data and paleoclimate data. And according to a recent paper, 2011 paper by Neil Roberts and colleagues, the best sources of information, the best proxy data for reconstructing past climates can be considered as isotopic records, because they can more or less unambiguously be related to climate forcing. But the problem, and as you can see, most of these data come from, for instance, deep sea cores. The problem is that they may not directly reflect the climatic conditions where people live. People do not live in the middle of the sea, so we need to find a way to solve that problem. So in other words, archaeologists and paleoclimate specialists should, and these are the two challenges maybe for us, improve proxies in terms of increasing the confidence in what these proxies actually mean. And second, try to devise multi-proxy approaches that establish unambiguous synchronisms and linkages between human activity, climate changes, and vegetation changes. And one possible solution to solve or to address these challenges is again proposed by Roberts and colleagues, saying that what we could do is adopt multi-proxy approaches combining archaeobotanical data derived from archaeological sites, for instance, charcoal, seeds, phytoliths, etc., with local pollen record and also locally derived proxy data that are less affected by human activities. And that way we can maybe disentangle the contribution of human activities and climate in the records that we observe. In a recent book, well, you can see, published in 2014, Paul Halstead has argued that for the last 10,000 years or so, the peoples of the Mediterranean have overwhelmingly relied and subsisted based on cultivated plants and domestic animals. So I'm here again repeating what I stated earlier, that any consideration of the effect of climate change on ancient societies in the Mediterranean should take into account the basic characteristics of Mediterranean farming system, pre-mechanized farming systems. And in fact, in the last few years, two models of Mediterranean agriculture have gained considerable momentum, and largely thanks to the development of bioarchaeological studies. And these are the models of intensive and extensive agriculture, with the first one characteristic of small-scale Bronze Age societies and Neolithic societies, and the other one being more characteristic of the late Bronze Age palace contexts of the Mediterranean. And here's a table that I tried to put together with all the characteristics we can give for these farming systems. And because none of you will bother reading it all, I just ask you to have a look at the motto entry of the table, which gives you in a catchphrase the essence of each agricultural system. So for the intensive agriculture, small-scale societies, the idea is to avoid putting all your eggs in the same basket. So the idea is we have a little bit of everything. We cultivate pulses, cereals, we do small-scale herding, and we disperse our land holding. And this is by opposition with the extensive agriculture, which is more concerned with the cultivation of large tracts of land, and also with the cultivation of cereals mainly, and with large-scale herding. So needless to say, one is quite flexible, the other one less so. And it's interesting because the one that is less flexible is the one characterizing those palace economies. Obviously, the Mediterranean is not Egypt, it's not Mesopotamia, so in most cases, people of the Mediterranean cannot rely on extensive irrigation to secure harvests in case of bad years. So they had to develop different coping mechanisms, among which you have here several, like crop diversification, mixed cropping, growing low-risk crops, dispersed land holdings, overproduce normal surplus, and also invest in livestock, which can be used directly in case of need, or traded against or exchanged for cereal in case of bad years. So livestock can be here understood as kind of walking larders. And maybe what I can add here, that it might be interesting, this particular point, for our future discussions, because all these buffering strategies adopted by Mediterranean farmers do have archaeological visibility. So in other words, they may have a kind of heuristic value for better understanding the impact of climates on past communities and trace differences between settlements. So this also connects with what Roberts and colleagues suggested, to combine local evidence with broader scale proxy data, or proxy data that are less affected by human activities. And probably I'm already running out of time, so I will be going through this very quickly. Just an overview of where does the idea of this workshop come from. We may think that, considering our present-day worries or present-day concerns with climate change, that the idea that climate influenced the end of the Bronze Age in the Mediterranean is quite recent. In fact, it's not. And it emerged, in fact, in the 1960s, 1966 to be accurate, with the work of this guy, Rhys Carpenter, who worked as a classical archaeologist at Bryn Mawr College. And in a small book, no more than 80 pages, this book here you have, Discontinuity in Greek Civilization, Carpenter suggested that a drastic climate change overwhelmed the Mediterranean lands about 1200 BC and lasted until around 850 BC, causing an enduring and disastrous destruction of the annual yield. Needless to say, this hypothesis at this time was not very well welcomed by both archaeologists, who at this time were more in favor of the migration hypothesis for the end of the Greek Bronze Age, and by meteorologists, because the data on which Carpenter based himself were quite slim. But nevertheless, in the 70s and 80s, the hypothesis of Carpenter was supported by the work of paleoclimate specialists, Bryson and colleagues, but also Barry Weiss, not Barry White, but Barry Weiss, who published this paper, The Decline of Late Bronze Age Civilization, as a response to climate change in this climatic change journey. And skipping a bit the details, we end up a few years ago where the multiplication of high-resolution paleoenvironment record led, I believe, to a growing consensus that the end of the Bronze Age in the Mediterranean, more particularly the Eastern Mediterranean, was in some regions, but by no means not all of them, experienced, in fact, drier conditions toward the end of the second millennium BC, and this has been very nicely demonstrated recently by pollen records from Israel, by Daphna Langut and colleagues, and also by David Kanevsky and colleagues in Cyprus and coastal Syria. And aside from these, apart from these hard data, this hypothesis has also been supported recently by modeling experiments. And another way also, or another approach to the problem has been performed in the last few years by Martin Finney and colleagues and Brandon Drake, who reviewed all paleoclimate evidence for the region in the late Holocene, middle late Holocene, and derived at different conclusions, which are not really mutually exclusive, but different nevertheless. So Drake suggested on his side that a multi-centennial drop of precipitations may have occurred at the Bronze Age-Iron Age transition, and the conclusions of Martin Finney and colleagues is here worth quoting in full, saying that there is well a general consensus that the time period between 1450 and 1850 BC was one of drier conditions and generally harsher conditions, but there is much intervariability superimposed on this general process. And of course, that's a bit what we are doing in the coming days. It's having a closer look at this intervariability, which is probably the key here in understanding the variable trajectories followed by Mediterranean Bronze Age communities towards the end of that period. And as a closing word, I could say that climate change, like collapse, is indeed too vague a word, and that we have probably reached at this stage a point where it's not enough to say that climate change pushed Eastern Mediterranean societies over the edge. So we need really to get to the data, and I believe we have the right people in the audience to do that. And also bearing in mind the wise words of Peter Kuhneholm in 1990, stating that it's not so much climate that is important, but rather man's perception of it. Thank you very much.